Hello students, today we are going to discuss properties of radicals. There are 4 different types depending on whether you're multiplying, dividing, adding, or subtracting. When you multiply radicals, you need to have the same index, and when you have the same index, it's just multiplying the things inside the radicand. So you have the nth root of a times b, which just simplifies to the nth root of a times the nth root of b. If I look at an example of this, I have the cube root of 12 times the cube root of 18. So I just multiply the inside. So I have the cube root of 216. And this is one you need to have memorized. And the cube root of 216 is 6. And that is your final answer for that one. When you're dividing, same rule applies. You just take the nth root of a divided by b, and that simplifies to the nth root of a divided by the nth root of b. So if we look at an example of this, I have the 4th root of 80 divided by the 4th root of 5. So go ahead and divide the inside. So I have the 4th root of 80 divided by 5, which simplifies to the 4th root of 16. Once again, this is one you need to have memorized, and the 4th root of 16 is equal to 2. Now we're going to go to adding and subtracting. When you add and subtract, you must have the same index and the same radicand in order to add and subtract. You also must use the factor tree in order to simplify. So if I look at an example of adding, I have the cube root of 4 plus the 7 cube roots of 4. In this case, I do have the same index and the same radicand, so I can go ahead and just add this. So I have 1 cube roots of 4 plus 7 cube roots of 4 is going to give me cube roots of 4. And that would be my final answer for that one. So that one I didn't have to simplify any further because it gave me the same index and the same radicand. If I look at one of subtraction, I have 12 4th roots of 2x to the 5th minus, this is a 5, sorry, minus 3 4th roots of 2x to the 5th. So if I go ahead and look at this, I do have the same index of 4 and the same radicand of 2x to the 5th. So 12 minus 3 gives me 9 4th roots of 2x to the 5th. Now let's go ahead and look at some examples. For my first example, it's a division problem. I have the same index of a 2, and these are different radicands, but that's fine for dividing. So I go ahead and just simplify this by taking the square root of 3 divided by 75, which simplifies to the square root of 1 over 25. And if I separate this, I have the square root of 1 over the square root of 25. Well, I know the square root of 1 is just 1, and the square root of 25 is 5. So my final answer is 1/5. For this next one, I'm sorry, I didn't finish writing the example. Let me go ahead and finish writing my example down. So it's the 3rd root of 54 plus the 3rd root of 2. And if you remember, when I'm adding and subtracting, I have to have the same radicand and the same index. So for this one, I do have the same index, but I need to get the same radicand. And I said in order to simplify, I have to use my factor tree. So I need to get this to be a 2. So if I break this up, I can do 9 times 6, breaks down further to 3 times 3, and 3 times 2. Normally, when you get the factor tree, you're looking for pairs of numbers because it's the It's the nth root of 2. In this case, I'm looking for the number of my index. So my index is 3, so I'm looking for groups of 3. And in this case, I have one group of 3, and so I'm going to pull that out. So I have 3 cube roots of 2. So whatever's left, which would be this 2, goes in the inside, plus I'm going to carry down my cube root of 2. So my final answer is I have 3 cube roots of 2 plus 1 cube root of 2. So I have 4 cube roots of 2. Let's look at one more example. This is a subtraction. Once again, you have to have the same index and the same radicand. I do have the same index, but I don't have the same radicand. So I'm going to need to use a factor tree to get my radicand to be 2. So break 512 down to 4 times 128. This breaks further to 2 and 2. This breaks further to 2 times 64. Then 8 and 8. Then 4 and 2, 4 and 2, then 2 and 2, and 2 and 2. Alrighty, once again, I'm looking for the number of my index. I'm looking for groups of 4. So I have, right here, I have this 2, this 2, this, all these, so that's one group of 4, and then I have these as well as these 2, so that's another group of 4, and I have this 1, 2 left over. So I have 2 times 2 to pull out. So I need to bring this down. So I have 12 fourth roots of 2 minus, don't forget that 7 that we had originally, times 1, 2 that I pulled out, and another 2 that I pulled out, fourth roots of 2. If I go ahead and simplify this further, I have 12 fourth roots of 2 minus 7 times 2 times 2 gives me 28 fourth roots of 2. And my final answer is going to be, so I have 12 minus 28, so that's going to be a negative 16 fourth roots of 2. That is all for today. If you have any questions, we will discuss it further in class.